Hello everyone, this is part 1 of HEC HMS Lecture. So let's begin. So let's talk about basin first. So a basin is the entire land area that drains surface water runoff, okay, to a common outlet point, such as a river mouth, reservoir, or sink. So when we say it's the entire land area, so as you can see in the image here, so this is the map of Korea right here. And then from map of Korea, we have this specific area right here that is from the Cheongju Dam area. So this is called Cheongju Dam area because at the outlet point, at the end of this basin, is a dam that's called Cheongju Dam. Okay, this is from South Korea. Okay, and so our basin is the entire land area like this that drains surface water runoff. So when we say surface water runoff, we're talking about water that's running on the surface, so such as rivers in this case. So all these rivers that flow into this one big river and then eventually flows out to this point at the end, right? And this is called a basin, okay, that has all these different features. Such as, okay, so subbasins, channels, and hydrologic features contributing to the outflow. So all the water that goes out to this point, that's called outflow. And then the subbasins are basically basins, but we divide this entire basin into different areas by using the water level stations as the new outlet points. So we'll be using, like, for instance, this water level station to make a new subbasin like this, and then another new subbasin like this, and so on. Okay, and then in modeling, a basin is the top level hydrologic unit that defines the boundaries of the rainfall runoff system. So yeah, a basin is the top level unit that defines the boundaries of the rainfall runoff system. So if there's precipitation in this area, then we are using this entire basin to determine how rainfall runoff affects this area, okay? So subbasin is, like I said, is a subdivision of a larger basin defined to represent smaller contributing drainage areas within the watershed. So in this case, like I said, we divided the entire basin by using the water level stations as the outlet. So instead of having one basin now, we have 15 different basins with 15 different outlet points, okay? So subbasin is a fundamental modeling unit that generates a discharge hydrograph. Remember this because this is important. At its outlet, representing the transformation of precipitation into direct runoff and base flow. So it transforms precipitation, so the rainfall that comes in this area, into 1 direct runoff and then 2 base flow within the contributing drainage area. Subbasins are the fundamental computational units in models such as HEC HMS, where runoff is computed before routed through channels, reservoirs, and junctions. And we'll talk about what these three are soon, okay? So let's first define what a discharge hydrograph is, okay? So discharge hydrograph is a curve showing how stream flow changes with time at a particular point. So if we look at the picture on the left here, so first we have the rainfall, okay? Rainfall in this form of bar graph. So the rainfall first happens, and then we have peak rainfall, so when there's most amount of rainfall. And after a certain period of time, it shows this peak rainfall, the influence of this peak rainfall shows after a certain time. So we call that time lag time. Okay, so after so when we have peak rainfall and after a lag time amount of period passes by, we have a peak discharge that happens in the stream flow. Okay, so stream flow is basically, you could think of it as like a river flow that happens after precipitation. But after precipitation, after peak rainfall happens, a peak discharge doesn't happen right away, because when it rains, some of the rain it gets stopped by like a rooftop or something, or sometimes some of it just goes straight to underground. So it takes time before the stream flow reaches its peak discharge, okay, because of all these different factors. And then we have the rising limb. So rising limb is this part of the hydrograph where it's going up. So as you can see, it's divided here by half, right? So this portion on the left side where the graph is rising is called rising limb. And then on the right side where the graph falls down, because now the peak rainfall is over, right? The influence of peak rainfall is over. So we have a graph going down, and we call that part falling limb, okay? And then you see that it's divided also right here. Okay, so whatever is down below here is called the base flow. Okay, and then all this is the direct runoff. Okay, and then we call the rest base flow down here. Okay. So what we just covered, direct runoff and base flow, right? So we have direct runoff and base flow. So types of runoff, we have surface runoff, overland flow. So when precipitation happens, some of it evaporates, some of it just doesn't go through soil and just runs on the surface of the ground. So that's called overland flow. Some of it goes through the soil and then flows through the underground, and we call that through flow or interflow. And some of it even travels down further down into below the water table, and it becomes groundwater. And so if we look at the explanation here, so this is water that flows over the land surface towards a river, stream, or other body of water. We call that surface runoff or overland flow, which was basically this upper part of the hydrograph, discharge hydrograph, okay? So that's direct runoff or surface runoff, okay? It typically occurs when the soil becomes saturated and can no longer absorb any more water. So when we say saturated, it means there's too much water in the soil, so there's not enough space left in the soil. So if this is soil and it starts raining, it's going to slowly fill up with water, right? And then once it's full and there's not enough space for water, no more water to go in, then it just starts flowing on the ground like this. Okay, so this process is called saturated. And then when it flows on the ground, then we have surface runoff or overland flow. Okay, so interflow is subsurface runoff or thorough flow. So interflow is the horizontal flow of water through the soil profile, moving below the surface but above the water table. So like I explained earlier, some water, instead of flowing on the ground or in the ground, like below the water table, it will flow just between the ground surface and the water table. Okay, so we call that interflow or thorough flow, same stuff, or subsurface runoff. Okay, and then we have base flow. So base flow is basically groundwater runoff. That is any water that's flowing below the water table. Okay, so every groundwater here is this entire area is base flow. So this is the delayed flow of water that has infiltrated deep into the soil and reached the water table. So yeah. So that's the base flow, and that is this lower part of this hydrograph right here. Okay, that's base flow. Hello there. So I'm adding this part because I forgot to mention when I was giving the lecture. So basically, direct runoff is combination of surface runoff or overland flow and interflow or subsurface runoff or thorough flow. Okay, so overland flow and thorough flow together combined is called direct runoff. Okay, not just one of them, both of them together. Okay, together is called direct runoff, and then everything that's below the water table is called base flow or groundwater runoff. Okay, thank you. So we have this graph that you can see to see how what happens to all the precipitation. So when we say effective precipitation is all the precipitation that actually hits the ground. So some of the rain that happens in an area, some of it will evaporate right away. Some of it will not even make it to the ground because there's like a building or some trees that blocks the rain from reaching the ground. Okay, so when we say effective precipitation, it means all the precipitation that actually hits the ground. Okay, so when some of the precipitation hits the ground, we have the channel precipitation. So that means some of the rainfall that hits directly to the river. Okay, that just goes straight to the river. And sometimes we call a river, a stream, also a channel. Okay, that's what we call it, channel precipitation. And then we have overland flow. So again, overland flow is the river. It's the precipitation that flows on the ground, okay, on the top of the surface, okay. And then we have infiltration. So infiltration means all the rainfall that goes into the ground, okay. And then some of it becomes interflow, and then some of it becomes groundwater flow or base flow. Okay, so when we say interflow, it's the water running between the surface and then the water table. Okay, so it's flowing right between the surface and then below the water table. Okay, and then groundwater flow is the flow that's happening below the water table. Okay, that's groundwater flow. Now we can divide interflow into rapid interflow or delayed interflow. So rapid interflow is the flow that goes that unites, that gets combined with the overland flow over time, but there isn't much of it. That's why it's like a dotted line here. So delayed interflow is like the most of interflow that happens. And then this contributes into the subsurface runoff, and then also groundwater flow is part of what we call subsurface runoff. Okay, and then we have the channel precipitation just going in here, so it's not part of what we call surface runoff. And we have overland flow, that's part of surface runoff, rapid interflow, that's part of surface runoff. But this one is there's little portion of it happens into it, okay? So we call surface runoff, subsurface runoff together as direct runoff. And if you forgot already, when we draw a hydrograph and we have divided into, base flow and then direct runoff. So when we say direct runoff, we're talking about combination of surface runoff and subsurface runoff. And surface runoff is made up of overland flow that happens on the surface, rapid interflow, some very few interflow that gets combined into overland flow, and then subsurface runoff is a combination of some rapid interflow and a delayed interflow, okay, and also groundwater flow. So you have to remember that subsurface runoff is made up of basically interflow and groundwater flow. So all the water that all the precipitation that went into the soil, okay. And then you have to remember that surface runoff is made up of mostly just overland flow, the water that flows on the surface, okay. And when we combine these two together, we call them direct runoff, okay. And then so after that, all of this gets combined and becomes storm flow, and then all the stuff that gets combined into subsurface runoff, it becomes what we call base flow. And then when you combine storm flow with base flow, we have total runoff, okay.